Hello everyone, welcome to my channel Learn Maths with Trisha. Today we are going to do cylinder and cone, very important questions including the previous year questions as well. So now let us dive into it. First, let us see the formulas. Slant height L is equal to root over r square plus h square. You can see I have made a column. You can take a screenshot of it. Now let us dive into our sums. Now for the first sum, it is said a well of diameter 4 meter was dug 21 meter deep. The earth is taken out of it has been spread evenly all around it in a shape of circular ring of width 3 meter to form an embankment. Find the height of the embankment. Now for all the embankment sums, it is more or less the formulas or the pattern is quite similar. So and one more thing I want to mention and add as well, when you are practicing the sums, you can also practice the sums that are in your book that is very similar to the sums that I am going to do. These sums are very important. These are all repeated pattern questions that have been repeating all over years. Please do see it carefully. Now on solving this sum, first see I have mentioned 1, 2, 3. These are 1, 2, 3 steps. First you have to draw the diagram as said from the question. Now first thing is we need to find the volume of the earth dug. That is, the formula is pi r square h. Just putting the formulas, just putting the values, we get 22 into 12 meter cube. Now for area of embankment, we know pi capital R square minus R square. That is pi 25 minus 4, that gives 21 meter square into pi. I am not simplifying the pi value here. As we require embankment, height of it, so we know height is equal to volume by area. So from it we are going to get the putting the values and just simplifying it, we get 4 meter. Now for the second sum, it is said water is flowing at 7 meters per second through a cylindrical pipe of internal diameter 4 centimeter into cylindrical tank of radius 40 meter. Calculate the increase in level of water in 30 minutes. Now first we have to convert all the given values in meter. So the internal diameters of pipe, that is given 4 centimeters. So we are converting it into 0.04 meter. Then pipe internal diameter, we are referring to as it as RP, that is 0.02. Now for velocity, flow velocity, V is 7 meters per second. And the tank radius RT is 40 centimeter, that is 0.4 meter. And time we are converting into seconds, that is 1800. Now for volume of water flows through the pipe in 30 minutes, that formula is V. V here is the capital V is equal to pi R square P, R this value, into Vt, that is the velocity. Now putting the values and simplifying, we get 5.04 pi meter cube. We are not going to simplify the pi here now. Again for the third step, volume of water rise in the tank, that means we have to find the height, that is V is equal to pi RT, here the capital RT, this the tank radius, into height. Putting the values, V from here we get that we are putting here, then pi 0.4 square into h. So we can cancel out the pi here and just simplify, we get 31.5 meter. Now for the third sum, a solid is in the shape of hemisphere where r is 7 centimeter, surmounted by a cone of height 4 centimeter. Solid immersed completely in a cylindrical container filled with water to a certain height. If the radius of the cylinder is 14 centimeter, find the rise in the water level. So this solid is immersed. After that, this was the initial volume. When the solid got immersed, it rose to this final volume. Now To find the volume of the solid submerged, first we need to take out the volume of it. So the formula is 1 by 3 pi r square h plus 2 by 3 pi r cube. Now simplifying it, we are just getting 1 by 3 pi r square, taking the common out from the first equation, we and h plus 2r. That is pi by 3 into 7 square into 4 plus 2 into 7, we get 294 pi centimeter cube. Again, we are considering the rise of the initial height is y. So let y be the height rise with radius capital R, that is 14 centimeter. Then we know volume of water rise in a cylindrical container is equal to volume of the solid immersed. So we are putting pi r square y is equal to 294 pi from the previous solving we got. So substituting the values according to y, we get y as 1.5 centimeter. So therefore y is 1.5 centimeter. So the initial rise to the final rise, the rise is 1.5. For the fourth sum, this figure represents a solid consisting of a right circular cylinder with a hemisphere at one end and cone at the other. Their common radius is 7 centimeter. The height of the cylinder and cone are each of 4 centimeter. Find the volume of the solid. So we know volume of the solid is equal to volume of cone plus volume of cylinder plus volume of the hemisphere. Putting each of the formulas for each cone, cylinder and hemisphere, we are getting 1 by 3 pi r square h for cone, pi r square h for cylinder and 2 by 3 pi r cube for hemisphere. Now we are just taking out the common and left with pi r square 1 by 3 into h plus 2 by 3 r. Again v into 7 square into 1 by 3 into 4 plus 2 by 3 into 7. We are just putting the values, and on simplifying it all, we get 1540 centimeter cube as the volume of the solid. Now for the fifth sum, a horizontal water tank composed of a cylinder and two hemisphere, and this is the cylinder. The tank is filled up to a height of 7 meter. Find the surface area of the tank in contact with water. So this is the diagram and this is the water in it. Now we know radius of the cylinder is equal to radius of hemisphere, that is 7. Length or height of the cylinder is 34 minus 7 minus 7, that is 20 we are getting. Now surface in contact with water is half into 2 pi rh, because half of it water is only in the half portion, not completely filled. That is, we are substituting the values and we are getting 440 meter square. Again the surface of each hemisphere in contact with water is half into 2 pi r square, that is pi r square. Substituting the values, we get 154 meter square. Now surface area of tank in contact with water, that will be 440 into twice into 154, we are getting 440 plus 308, that is 748 meter square. Now for the sixth sum, a metallic cylinder is cut into two identical halves. So this is the cylinder, it's cut into two halves. Along its height, the diameter of the cylinder is 7 and height is 10. So we have to find total surface area of both the halves and cost of painting the two halves at the rate of 30. Now for diameter, we know that is 7. So radius will be 3.5, height is already given as 10. Now total surface area of both the halves will be total surface area of the cylinder plus area of the two rectangles that it is forming. See, there are rectangles. So that is 2 pi r h plus r into plus 2 into L into B. So we are simplifying again, that is 2 pi r h plus r plus 2 into h into d. That means height into distance. Now again we are substituting the values, just putting the values, simplifying and getting 437 centimeter square, that is the total surface area. Now for the part B, it is cost of painting, so that will be total surface area into rate, that is 437 into 30. So we are getting it as rupees 13,110. So we are going to stop the class here for now. We are going to continue the important sums again in the next class. Thank you so much for watching. Do like, share and subscribe. Thank you.